results. This is not my normal type of experiments that I like to mess with, but I happened to see this on YouTube on another fellow's site, and I thought it was very interesting. Take a piece of galvanized and pipe, metal, in this case angle iron, drive it in the ground a foot or two, and I've got a piece of telephone wire run from it, mainly so I can connect the two. I don't know if you can see it very well. I can't even see it in the camera. But anyway, you step off, in this case about 60 feet, and according to other things I've read on other websites, if there's trees in between, you get better current flow. But anyway, it's called an earth battery. In researching it, I found out that over half of the telegraphs in the United States and Europe in the mid-1800s ran off of earth batteries, and they were capable of sending messages anywhere from 300 to 400 miles. Anyway, it's called an earth battery, and I stuck a piece of half-inch copper pipe in the ground here. Oh, by the way, they're running north and south, and with the copper north and the galvanized south, and the copper is driven down just a little deeper. Actually, copper is driven down about 2.5 feet deep. This was a 5 foot. Where is it? Can't find that sucker. There it is. Anyway, just so you'll know what's going on, the wire itself. Where is it? I can't find that sucker. There we go. There we go. I've got the wire is not actually connected to the copper pipe. I've just got it wrapped around so I can pull on it and get it tight to keep it up off the ground. The actual bare end is right here, and that's where it's tied into the negative end, which comes from the galvanized. And then, of course, right here, I can't find anything in this thing. Here we go. Here we go. Then my positive lead is touching the copper, and right now, as you can see, we're producing 1.016 volts. And if you look at the little V to the right, you can see it's full voltage. This is amazing.
This is the famous lemon battery. Let's make one. We know that a battery can be created by suspending two different metals in an acid. Lemons contain citric acid. If we insert a galvanized nail coated in zinc into one side of our lemon, then make a slit and insert a copper penny in the other side, we should have a battery. The voltmeter confirms that our two metals, zinc and copper, suspended in the lemon's citric acid, create a measurable voltage, in this case just over 1 volt. The red lead from the meter connects to the plus side of the battery, the black lead to the minus side. Reversing the leads, we see a minus sign on the meter, meaning I have the leads connected backwards. The copper penny is the plus terminal of this battery. Now we have over 3.5 volts. Connecting our LED, I can now detect a very tiny glow. Dimming the room lights and looking closely, we can see our LED is glowing. 4 lemons create enough voltage and current to create a very dim glow.
The experiment I will be doing today is called potato power. I'm going to take these 2 potatoes to power this one calculator. As you see, this calculator has no batteries in it. The materials you will need today will be 2 potatoes, 2 galvanized nails, 2 pennies and 3 wires. Here are the step-by-step directions. Take a penny and poke it into the potato. Do that on both potatoes. Then take a galvanized nail and poke it into both potatoes. Then take a wire and connect it from a galvanized nail on one potato to a penny in the other. Then flip the calculator over and take a wire and connect it from the penny on one to a battery terminal in the calculator. Do that on the other side too. When you flip it over, it shall work. What I learned from this experiment is that when you take the zinc from a galvanized nail and the copper from a penny, it makes a chemical reaction. It takes a chemical reaction to make electrons flow, and that's how the calculator works.